This is the third and final part of section 11.3 lecture. So if we look at the applications of some of what we just learned. For example, write an equation of a parabola that has the same shape as the graph of f of x equals negative 3x squared, but with a vertex of 5, 3. Well, remember, the vertex form of the equation is f of x equals a times, in parentheses, x minus h squared plus k. Remember, h and k are the coordinates of the vertex. So how do we know what a is if we want to find one that has the same shape as negative 3x squared? Well, the a on negative 3x squared is the negative 3. So we have negative 3 times x minus the x coordinate of the vertex, because remember those coordinates are h and k. So minus 5, whole thing squared, plus the y coordinate of the vertex, which is 3. And there is our equation. Okay, let's look at number 6. A person standing close to the edge on the top of a 200-foot building throws a baseball vertically upward. The quadratic function s of t equals negative 16t squared plus 64t plus 200 models the ball's height above the ground. S of t in feet, t seconds after it was thrown. So the first part says, after how many seconds does the ball reach its maximum height? And what is that? So here's what we have. I'm going to draw a little picture. We have a building. So here's our building. And we're standing right here. And we throw a baseball upwards. So it goes up. And then it comes down and eventually hits the ground. And we know that the height of our building is 200 feet above the ground. So the maximum height is where? It's at the vertex. So we need to find the vertex. So remember, the x-coordinate of the vertex is negative b over 2a. b is 64, so a negative 64 over 2 times a negative 16, which is negative 64 over negative 32, which is 2. And I shouldn't have said x-coordinate here. I should have said t-coordinate, because our independent variable this time is t, not x. So now we need to find the y-coordinate. So after 2 seconds, it reaches its maximum height. But how high is that? Well, f of 2 is negative 16 times 2 squared plus 64 times 2 plus 200, which is, if you put that in your calculator, or you can do it the long way like I'm about to do. 2 squared is 4. 64 times 2 is 128 plus 200. negative 16 times 4 is negative 64. So the highest point that it reaches, which is after 2 seconds, is 264 feet above the ground. So how many seconds to the nearest tenth does it take the ball to reach the ground? Well, when the ball reaches the ground, its height above the ground is 0. So we essentially need to find our x-intercepts. So negative 16 t squared plus 64 t plus 200, where that equals 0. Now, I am going to factor out the greatest common factor because that's going to make it easier in the long run. And I'm going to factor out a negative of that because I don't like negatives on my squared term. So I'm going to take out a negative 8. That leaves me with 2t squared minus 8t minus 25. And I can divide both sides by negative 8. And that gives me 2t squared minus 8t minus 25 equals 0. Now, this is not going to factor nicely for us. So, what we should do is use the quadratic formula. So t equals negative b plus minus square root of b squared minus 4ac all over 2a. So b is a negative 8, so that's 8 plus or minus the square root of 8 squared minus 4 times 2 times negative 25 all over 2 times 2. So if I go up here for space, that equals negative 8 plus or minus the square root of 64 plus 200 divided by 4. Which equals negative 8 plus or minus the square root of 264 over 4. Sorry, not a negative 8, that's a positive 8. Don't know why I just decided to put a negative in there. So if we use our calculators, we get, if we do 8 plus square root of 264 over 4, we get approximately 6.1 seconds. Or if we do 8 minus the square root of 264 all over 4, we get approximately negative 2.1 seconds. But there's no such thing as negative time in this instance, so we throw this answer away and we keep the 6.1 seconds. So now, find S of 0 and describe what it means. So S of 0 means we just plug 0 in for t. So we have negative 16 times 0 squared plus 64 times 0 plus 200. The first term is 0, the second term is 0, so that just equals 200 feet. What does that mean? Well, at 0 seconds, the ball is 200 feet above the ground. Or more importantly, this is what we would call an initial condition. We throw the ball from a height of 200 feet above the ground. Which, if you think about it and go back up here, is exactly what our picture indicated, right? Because we were standing on top of a 200-foot tall building when we tossed the baseball upwards. So that's the end of section 11.3. You're now ready to do the homework.